Black holes are mysterious objects in space. They are regions where gravity is incredibly strong, so strong that nothing, not even light, can escape their pull. Imagine a giant vacuum cleaner in space, sucking up everything that gets too close. That's kind of what a black hole is like. Black holes are invisible to us. We can't see them directly because they don't emit any light. However, scientists can detect them by observing their effects on nearby stars and gas. These objects behave strangely when a black hole is nearby. They might orbit very fast or get stretched and pulled in a cosmic tug-of-war. Black holes come in different sizes. Some are small, only a few times heavier than our Sun. Others are supermassive giants, millions or even billions of times heavier than the Sun. These supermassive black holes are found at the centers of galaxies, including our own Milky Way. How do black holes form? Most black holes are born when massive stars die. Stars are like giant nuclear reactors, constantly fusing atoms in their cores to produce energy. This energy creates outward pressure that balances the inward pull of gravity. But when a star runs out of fuel, the outward pressure stops. Gravity takes over, causing the star's core to collapse in on itself. This collapse can trigger a powerful explosion called a supernova. If the star's core is massive enough, the collapse doesn't stop there. It continues to squeeze until it becomes infinitely dense, forming a singularity, the heart of a black hole. Imagine all the matter of a star crammed into a tiny point with no size at all. That's a singularity. Not all stars become black holes. Our Sun, for example, is not massive enough. When it reaches the end of its life, it will swell into a red giant and eventually shrink into a white dwarf. Black holes only form from the most massive stars in the universe. Let's take a closer look at the anatomy of a black hole. Surrounding the singularity is a region called the event horizon. This is the point of no return. Once you cross the event horizon, there's no going back. The gravity is so strong that nothing, not even light, can escape. Imagine a waterfall where the water flows down so fast that even the fastest fish can't swim back upstream. That's kind of like the event horizon. Around the black hole, you'll often find a swirling disk of gas and dust called an accretion disk. As material falls toward the black hole, it spins faster and faster, heating up to millions of degrees. This hot, glowing disk is what makes black holes visible to us, even though we can't see the black hole itself. Black holes are still a mystery to us. We don't fully understand what happens inside a black hole or what happens to the information that falls in. It's one of the biggest puzzles in modern physics. In 2019, scientists made history by capturing the first ever image of a black hole. This incredible feat was accomplished using a global network of telescopes called the Event Horizon Telescope. The image showed a bright ring of light surrounding a dark center, the black hole's shadow. This groundbreaking image provided the first direct visual evidence of black holes and confirmed many of our theories about these enigmatic objects. Scientists continue to study black holes using telescopes and computer simulations to unlock their secrets. These cosmic monsters continue to fascinate us, challenging our understanding of gravity, space, and time. As we learn more about black holes, we'll undoubtedly make even more exciting discoveries about the universe we live in.